everyone. Today we will solve the following exercise. Here we have to find all the functions f defined from R to R such that for all x and y in R, f of xy equals x multiplied by f of x plus y multiplied by f of y. Then for the solution, of course, if you want to solve it, pause the video and think about it for a few minutes and then see the solution. Well, then to solve this problem, at first we try to simplify this expression, the expression which I call, for example, this big one. Then for x equals y, we have that the equation 1 implies that for all x in R, we have f of x squared equals 2x f of x. And in this equation, for example, if we replace x, or for x equals 0, we get f of 0 equals 2 0 by f of 0, which implies that f of 0 equals 0. The same thing for x equals 1. We get f of 1 equals 2 multiplied by f of 1, and this implies that f of 1 equals 0. Also for x equals 2 and y equals 1, if we replace x and y in the equation 1, we get that f of 2 multiplied by 1 equals 2 multiplied by f of 2 plus 1 multiplied by f of 1. But f of 1 equals 0. This is proved here. And then we have this implies that f of 2 equals 2 multiplied by f of 2, and this implies that f of 2 equals also to 2. And here the idea we get, or this leads us to think that that perhaps we have for all a in R, we have f of a equals 0. And of course, in mathematics, perhaps is not admitted, is not accepted in mathematics. We have to prove all the things we say, and to prove it, or to try to prove it, we suppose we suppose that it exists a number of real a in R such that f of a equal it is different from 0. Is different from 0, or it exists it exists a real a 0, to say that it is fixed, to not think that I'm speaking about all a. And here we have, in this case, or then we have the following assertion, or the following thing. We have f of a 0, it equals to f of 1 multiplied by a 0, which is equals, using the equation 1, to 1 by f of 1 plus a 0 multiplied by f of a 0. And this is implies, which leads us to say that f of a 0 equals to a 0 by multiplied by f of a 0. Why? Because we know that f of 1 it is equal to, excuse me here, sorry, it is equal to 0. It is proved before. Then we have f of a 0 equals a 0 multiplied by f of 0, and this implies that f of a 0 minus a 0 multiplied by f a 0 equals to 0, which implies, or which is the same thing as 1 minus a 0 multiplied by f a 0 is equal to 0. And this implies this leads us to two cases. The first case is we have that a minus a 0 equals 0, or f of a 0 equals 0. We have case 1 and case 2. Or the case, let's begin by the easiest case, which is the second case. The second case is easy to prove, that is impossible. We have f of a 0 equals 0 is impossible. Why? Because we have supposed before that f of a 0 it's different from 0 here, because f of a 0 is different from 0. Then the second case, or second case, 1 minus a 0 equals 0. This is implies, or this is it means that a 0 equals 1, and which implies that f of a 0 equals f of 1, which is equal to 0, which implies that f of a0 equals 0, and also in this case it is impossible. It is impossible. Then this supposition, it is false. It's false because it leads to two contradictions. It is a contradiction in two cases. Then what we have supposed before is false. If it's false, then we have its negation is true, which is finally we have for all real a in R, we have f of a equals 0. Then the only function which verifies the equation big one is this function, the function which is equals to 0 for all real in R. And finally, thank you for watching.